In the previous tutorial, we learned about how you can define a class, for example, points, and then you can define one section called attributes, where there's simply just class level variables that you can use for every method, including constructor. So constructor is the only kind of method we have gone through so far. Okay, let me just recap very quickly the details you have to pay attention to. If you have got lost in any of the details, please check the previous tutorial video. For the constructor, it has to be the same name as the class name. And you can define as many versions of the constructor as you like, as long as their list of parameters can be distinguished on their types. For example, over here, you can see we got 2 parameters over here. We also got 2 parameters over here for version 2. However, the type for the very first one parameter, double versus char character, it can be distinguished. So compiler wouldn't complain. Okay, and then if you go to the point tester, which is the only class with the main method, so we can execute it as a Java application. For example, over here, you can see we declare a variable p1 of type points, which means p1 is only going to store the address of some point objects. And then the right hand side of the assignment, we have the new keyword. Whenever you have the new keyword, what has to follow after the new keyword over here is going to be the constructor of some class. In this case, it's going to be the point class. And whenever you see the point constructor over here of a particular class, you're going to visualize what's happening over here. So we talk about either you can see from the memory point of view, which is lower level, or you can simply draw a box. Okay, pretty much like how I did previously. For example, you can see P1 basically store the address of some newly created object over here in the blue. And then the type of the object simply points. As soon as you know about the type of the object, you would know the structure of the points, because we know that every object is instantiated from some template. In this case, the template is simply the class point. And each point can be characterized by all its attributes. In this case, it will be x and y. That is why we put x and y here in the left column here. And then we also got object-specific attribute values, which can be 3 versus -4. That is why we got 3 versus -4 over here. And similarly, we can create different objects, P1, P2, P3, and P4. And let me emphasize again, P1, P2, P3, and P4, each one of them, they do not store the entire objects. That is, they don't store x and y values. They don't. They only store the address of the objects in the memory. Okay, if you haven't really been comfortable with this idea, please look into the previous video to review very quickly. Okay, so now in this video, and another thing that we talked about in the previous video was about the use of this keyword. Okay, basically, if you use this keyword in the constructor, that means if you have the variable name, for example, over here, let me go back to the point class. If you have the input parameter name, x over here, that is the same as the attribute name, you want to have a way to distinguish whether the x you talk about is the input parameter, you can see it's highlighted, or the x is the x attributes in the current class. Okay, so we talk about the two. We're going to see that this keyword being very useful for helping us to trace the program. So that's something I would like to focus on for the current video and the next video when we talk about 2 other methods. Okay, let me just go back to the original ingredient summary over here for object-oriented programming. Let me just go over that very quickly together with you. So far we covered about constructor. So now we're going to talk about another 2 kinds of methods. One is commutator, and the other kind is called accessor. Okay, we're going to talk about accessor in this current video. Okay, if you just interpret these 2 kind of methods literally, accessor simply means you're going to basically query. You're going to query about the object you have just created. Okay, it's cube. Sorry, it's let me spell that properly. You're simply just going to make an inquiry about some information about the objects. Okay, for example, given a 2-dimensional point, you want to know what's the distance between the point and the origin. Okay, you want to calculate the distance. That's something we'll do to show you how you can do that programmatically. On the other hand, for mutator, if you interpret literally, if you only look at the mutator, the word mutates, that means to change something. Okay, mutator, every time you do mutator, that means you want to modify the attribute values for your objects. That's something we'll see in the next video, but let me just mention that first. Modify the attribute value. Okay, you can see that. So now we got these three kinds of methods. Constructor is for creating a new instance that is guaranteed to have a unique address. And accessor is going to ask something about the object that's being created. Okay, and also mutator is to change the attribute value for the objects. So every time after a certain change, you can ask the same question again, and the answer might be different. Okay, that's basically just simulating to what happens in real life. Okay, and then we're going to talk about the dot notation. So whenever, for example, if you have a points, let's say it's called P1, okay, versus P2. Okay, if you say P1 dot and P2 dot followed by something, what does that mean exactly? That's something we'll also show you exactly what it means. Briefly speaking, dot simply means because P1 and P2 objects, they simply store the addresses of some point objects. So the dot is simply just say, look up the address that is stored in the object variable, and then go to that corresponding address in the memory and look up the maybe attributes or try to execute some methods. So the dot over here, you can think about is simply just to look up somewhere in the memory. Okay, that's something we'll see concrete examples in this video and the next one. So what I would like to do for this current video, we're going to look at the accessor. Okay, let me open a blank page and then let me go back to Eclipse and let's do it. I'm going to show you basically a few accessors, so you will know how to define them. Okay, and we also have to know about the syntax. Okay, let me first of all go to the point class. Okay, so now we already got the attributes, we also got the constructors. Let me maximize this. So now the third section here, we're going to define accessors. Okay, let me just make this a little bit to the middle so it's easier for you to see from the screen. Okay, so now we're going to define accessors. Methods for inquiring about the point about a point. Okay, and then let's start with something simple. Okay, so let me just give you a few so you can actually get some idea. Let me define all the three I have in mind, and then we're going to trace it. Okay, so now the first one, so here's the syntax you have to follow every time for defining either accessor or mutator. Of course, for defining constructor, you always have to give just the name of the class. That's the rule. So now for accessor and mutator, so here's the syntax. Let me just give you a quick summary. So for defining methods other than constructor. Okay, how do you define the syntax for a method that's other than constructor? So here's the syntax. Okay, you have to give, let me just give some placeholder for you. First of all, you have to give a type over here. So this has to be a return type. Okay, return type can be int for integer, it can be double, can be string, it can also be person, like a class, right? Remember we said before, every class that you define on your own, it can also be used as a type. Okay, basically you gotta it's a placeholder for some return type over here, followed by the name of the method. Okay, followed by the name of the method. And also it's going to be starting with opening parenthesis, closing with close with the closing parenthesis, and then you're going to have a comma separated parameter list. Okay, you have as many parameters as you like. Of course, you may have empty lists of parameters. Okay, so these are list of input parameters. So this is the general syntax for any methods other than constructor. So the method can be either accessor or it can be for mutator. Okay, the syntax will be the same. So now for the case of accessor, the return type is very important because it tells that whenever you try to call this particular method, it's going to give you back this particular type of value. Okay, and then of course after that you're going to have the opening and closing curly brackets and then do something over here, right? That's something you can write. So now having this in mind, let's see exactly how we can define our accessors for the point class. So let's go back to the Eclipse over here. The first one I'm going to define is going to return and let's say a double. Okay, let's say we want to know what's the distance between the points, objects, and the origin. Origin, of course, has the x and y coordinates both being 0. So I can say get distance from origin. Okay, as you can see, the naming convention for the methods would be, it's going to be a compound word, and the first compound word is going to be all lower cases. And then starting from that, we got capitalized word. Okay, so get distance from origin. So in this case, I'm not going to take any input parameter. I will try to give you a little bit hints, a little bit tips about how you decide the number of parameters you should have when you design your methods. I'll get there, once we see more example. For now, let's simply assume when you want to know what's the distance between the current points and the origin, because origin is somehow known to us already, which is 0, 0 always. So we don't have to take the origin as an input. That's kind of the rationale. Okay, and then how do we define this? So this is the pattern I would suggest you do. Okay, you always have to initialize some variable. Let's say, for example, that's going to be of the same type as a return type. In this case, I can say double and then result, which is going to be the distance, and it's going to be of some initial value. Let me just say 0.0 for the double. And then you want to make sure eventually you must have a single return statement to return the output. So you would say return the result. It is really important that, of course, that will make the method compile. You want to make sure you always initialize a variable that's of the same type as the return type for the method, for the accessor. And on the other hand, you should also make sure you have a single return statement. Of course, when you get more experience, you might realize you can have multiple return statements for your methods, but you got to be very careful when you have multiple return statements. I would say you can always keep things simple. Basically, what you would do is, once you initialize the result, you can say reassign the result so that it is going to store the correct output value to be returned. Okay, so that would be the tips I would give to you. But I would say for you as a beginner, always try to keep the initial result and also the final return. Okay, keep it simple. So now for this particular method, accessor, what should we define the accessor so that it's going to reassign the result to be the distance of the point from the origin? Let me give you a little bit intuition over here. Okay, let's review how you will calculate the distance between a point and its origin, and the origin for the two-dimensional plane. So let's say over here we have a two-dimensional plane. So we got the y-axis over here. We also got the x-axis over here. Okay, let's say over here we have the points that we're talking about. So we're going to make use of the keyword this, which means which point are you talking about? Because you might be talking about P1, you might be talking about P2, you might also be talking about P3, right? Depending on which point you're talking about, the distance from that point to from the origin will be different. So the point we are talking about is really so-called the context objects, which I'll show you exactly how that would look like in Java programming. But let's say currently we are talking about P1. Okay, if we are talking about P1 specifically, so we'll refer to P1 in the definition of the accessor method as this. Okay, if we are talking about P3, then P3 will be this. Okay, so now if we want to know what's the distance between P1, which is this, between the origin, so we learned about, so origin we know is always going to be 0, 0. Right? P1 is also going to be the x value for P1, also the y value for P1. We know that it's simply just going to be x minus 0 squared plus y minus 0 squared, right? Which is going to be x squared plus y squared. That's something you learned from the high school math. Okay? If you are not comfortable with the formula, please refer to your textbook. Okay? So now that's how we're going to calculate. Again, the current objects we are talking about to calculate the get distance from origin can either be P1, P2, P3, or any other instance that we create from the point template. Okay? So now if I go back to Eclipse over here, so what I would do is I'm going to calculate it. So result initially is just going to be 0.0. That's okay. It's only the initial value. Let's now reassign the result to the correct value. How do we calculate the distance? I can say result is simply assigned to, let's say we're going to use square root, right? For the square root, I would suggest we use some library class. But when you complete your lab exercises, you can use square root for completing the math. That's okay. unless you're told you cannot use any library method. But I would say for numerical calculation, typically you can use library classes in your lab test. But later on, we're going to say for collecting objects in your class, you have to use primitive array. You cannot use any library class like arrays or linked lists, array lists, etc. Okay, I'll make it clear when you see the instruction. But in this case, we can use math. So for this part here, you can just take it for granted. If you want to calculate doing some mathematical calculation like to the power of, or sine, cosine, or pi, or even or square root, you can use the math class. Okay, you can spell it precisely like this. You can say math dot square root. We want to say the square root of two numbers over here, right? So the first number is going to be x squared. So I'm going to say, you can either say this dot x multiplied by this dot x. So that'll be x squared. That's one way to go. Or you can say, use the math class. You can say math dot power, okay, is going to be y to the power of 2. Okay, that will also work. Okay, so this is just something I want to show you, so you can feel free to actually Google the math class and see how it works in general. Okay, so I definitely want to calculate the square root of, oh, sorry about that, it's going to be x squared plus y squared, so it should not be comma. Okay, so it should be x squared, which I don't use the power method, plus where I use the power method to calculate y squared. Okay, they are basically corresponding to this mathematical notation over here, the same. Okay, so the square root sign over here is the SQRT method I'm talking about here. Okay, so once I reassign the result to be this particular calculation, which I'll trace together with you, it is going to be reassigned to the correct value. And then after that, we can now be safe to return this particular correct output, depending on what this is. This over here may be P1, in which case it's going to apply the x and y value for P1. Or this over here might be, for example, P2, in which case we're going to apply the x and y value for P2, which might be different, right, from the x and y values for P1. Okay, that's about the very first accessor method we defined. And notice one thing. Even though I only have one single line over here for the reassignment to the result, two things to notice. In general, as the problem for you to solve gets more complicated, you might have more than one line to actually reassign the result value. For example, you might even have to use an if statements. You may even have to use a for loop. That's something we'll see in the later tutorial videos. And number two, you don't necessarily have to call this local variable here, which is going to be returned as a result. I just want to make it like a pattern for you, so you can always declare the result of the same type as the return type, but you don't have to call the result. You can definitely rename it to any name that you prefer, as long as it has the correct type that matches the return type. For example, I can simply choose result, and I can right click, and then I can simply go to refactor and say rename. In this case, I can simply rename result maybe into, let's say, distance. Sorry. You can see while I'm typing over here, every occurrence of result has been changed to distance. Okay, and then I'll say enter. So now it has been renamed systematically. So it's the same idea. So we're just reassigning the distance. Initially, it's simply just 0.0 as the initial value. Eventually, distance over here is going to store the value for this particular expression over here. Okay, it's also going to work. That's about the first accessor method. Let me do another similar one, but with a different return type, right? Remember, every time when you define the accessor or mutator, you always have to give, first of all, a return type, followed by the name of the method, and give a possibly empty list of parameters, or one or more parameters. It's really up to what you need. So now, for the second one, let's do a string return type. Let's say string over here is going to return a string value, which might be useful for printing out to the console, for example, in the main method. So let's say get description. We want to get the description of, for example, if the current object happens to be P1, we want to know what's the x and y coordinates, maybe in this form. It's going to be parentheses followed by the value of x with a comma followed by the value for y of P1, and also followed by the parentheses, right? That's maybe the string description we would like to have for either P1 if P1 is this, or P2 if P2 is this, and etc. So let's go back here. Let's do that quickly. Get description, and then in this case, I also don't take any parameter over here. The reason being, very briefly speaking, because if you want to get a description of let's say for P1, all you need is the information about the X of P1 and also the Y of P1, in which case you already got access to them already, which is here, X and Y. Okay, so we don't need any extra input. You only put parameters over here when you need some extra input for anyone who's calling this particular method. That's the general principle. Okay, and then you're going to, again, I'm going to declare maybe, let's say I'm going to declare a variable that's going to be of the same type as the return type over here. Let's follow the pattern so you can always get something that will compile to begin with. So string, and then I would say description. Initially, maybe just empty string, for example, right? Just nothing meaningful. And then you can see what's missing over here. If you move your mouse over here, it tells you the method must return a result of type string, which means you're missing a return statements. Because you can see the type over here says you must return a string value, but you only have a local variable here called description, but you never make it available to outside. To make it available to outside, you have to have a return statements. Okay, in this case, you're going to say return description. Okay, and then in the middle, similar to before, I'm not going to repeat this. We're going to reassign this description over here for as many times as we like, as long as its final value to be returned is going to be correct. Okay, let me just do it like this. I can say description is simply reassigned to from empty string to, let's say it's going to be opening parenthesis plus this dot x is referring to the attribute value, like how we did it in the constructor, plus and also followed by a comma and space plus this dot y followed by the closing parenthesis over here. Okay, that's the second accessor method, which you can see the pattern is very similar to how you did it for the get distance from origin. The only difference is the return type. You can see the return type over here is double. That is why we initialize the double variable and return it. And over here, the return type is actually string. That is why we declare a string variable over here and return it at the end. Okay, so it depends. It really depends on the return type. Later on, we're going to see the return type can be even more complicated. For example, array. Okay, that's something we'll see later. Okay, so that's the second accessor method. I want to show you one more accessor method which will take an input parameter. Okay, so let's say this. Conceptually, if I go back to iPad over here, so over here I simply, let's say if this is actually P1, I want to know what's the origin, what's the distance from P1 to origin, right? So origin is always fixed to be 0, 0. Let's make it more general. I want to know what's the distance between, let's say, 2 points. Let's say I know this is actually P1. I want to know what's the distance between P1 and P2. So how do I calculate the distance over here, right? That's something I'm trying to handle. In this case, I would really need to know which point am I talking about. Given the points, I want to know what is distance from another point. So this another point is the input value I need to supply. Okay, so in this case, I do need some input parameter. So what I would do is, I'm going to say double. Again, the distance will be a double because all the x and y coordinates can be a double. And also we're going to do some square root calculation. So double, let's say get distance from, okay, rather than get distance from origin. So now we want to know from where. So over here, we're going to declare some input parameter. And for input parameter, it's going to be a comma separated list. Okay, and now in this case, let's say we only have one single parameter. And for this single parameter, we need to have a type, and also we need to have a name. Remember I said before, now since we are doing OOP, so the class name can be a type. So now I can simply say, points over here. So that's going to be points and then other, let's say. And then we're going to see how this will work. So as before, we're simply just going to say double over here, which is going to match the return type over here. And then we're going to get, let's say the distance, which is going to be initially 0.0, and eventually we're going to return the distance. Okay, that's what we'll do. So now what should we do over here? Okay, let's review very quickly the formula we have. Okay, let's say over here, if you think about conceptually, let's say this is P3 and this is P4. Let's say the current points we are talking about, which is this, is P3, right? So over here we have the x value for P3. Okay, okay, how about this? You can think about if this is x1, x2, and let's say this is, let's say this is x1, and this is y1, and let's say this is x2, this is y2. Okay, basically the formula would just be x1 minus x2 squared plus also y1 minus y2 squared. Okay, that's the formula we're familiar with. Okay, let's see how we can code this into Java. Let's go back to this method over here. So what I would do is I'm going to use the same idea over here to use the square root method from the math class to calculate the square root. So I can simply say distance over here is assigned to math.sqrt, and then what should be the square root? It's going to be x1 minus x2. Okay, x1 is going to be the x for this, for the current objects. So I'm going to say this dot x. I'm going to trace the code together with you, so don't worry. Minus, and now we want to know what's the input. Input is actually other. Okay, and over here we're going to say other dot x. Okay, and then over here we want to say it's going to be to the power of 2. Okay, so what we'll do is over here, let me try to make this into a few lines so it's easier for you to see. And then we're going to say math.power this particular number to the power of 2. Okay, and then plus. Okay, math.power, and then okay, let me just finish that and then I'll go through that with you. And then I can say this dot y minus other dot y, and then to the power of 2, and then like that. Okay, sorry, not power, it should be pow. Okay, that's the expression. You can see everything compiles. Basically what we're trying to say is we're going to call the square root method from the math class, where I'm going to give this particular addition expression. You can see there's a plus over here. The left hand side for the plus is going to be this dot x minus other dot x to the power of 2. We're going to see exactly how that's going to be executed. And the right hand side is going to be this dot y minus other dot y to the power of 2. Okay, so that's what we're going to do. So now let's see. So now we got 3 different accessors. You can see the first 2, they have different return types, but both of them got empty list of parameters, which means when you try to call these 2 methods, you don't have to give any inputs. On the other hand, you can see the third accessor we have over here. Every time you call that, you are obliged to actually give one input value in order to call that, which is another point. Okay, so that's something we would like to trace for you. But before we trace, let's just get to point tester over here, and with the main method, let's simply just reuse the points we have over here. Okay, and then let's simply just try to do the things together. Let's say we already got P1, P2, P3, P4. That's something we already have. But now we would like to actually calculate, let's say, the distance from the origin and also the distance from each other. Okay, I'm just going to use maybe 2 of the points just to illustrate. Okay, we already know from the previous tutorial video how you can visualize the creations of these 4 objects. So I'm going to omit that part. I'm going to draw the diagram as well, but I'm going to omit the process of drawing those diagrams. And then over here, let's say we got, let's say we only worry about, let's say P1 and also P3. How about that? Okay, so let's say over here, system.out dot, let me just say this. We can say double distance 1. Okay, let me make it even simpler. I can say this one is going to be P1 dot. I'm going to explain the dot notation in just a moment. I'm going to make a snapshot and explain it in iPad. Dot. Every time you want to call a method, you must give some variable of type, of the correct type. In this case, because you want to call the method from the point class over here, right? As you can see, all the methods were defined under the point class. So that means you must give and variable that is declared to be of point type. Okay, when I say p1 over here dot get distance from origin, I'm going to get something over here. Double distance 2 is p1 dot get distance from origin. Okay, you can see that I'm really trying to call the same method over here, and what I meant to say here was p3. Okay, what you can see is get distance from origin is actually called twice, so the first time and the second time. However, you can see before the dot, for one case I got p1, and for the other case I got p3. Okay, that's something that's really the essence for object-oriented programming. That's something I will explain in just a moment. Let me finish this, and then I would say another double. Let's say distance number 3, and now I'm going to say p1 dot get distance from another point. And over here you can see as soon as I hit enter to complete the code, it gave me 4 different choices, which can be p1, p2, p3, and p4, simply because if you look at the parameter type over here for get distance from, it's simply points, which means any variable that is of type points can be used as an input value. In this case, what do we have? You can see we got p1 of type points, and p2 also of type point, and also p3 and p4 as well. Okay, so now let's say I want to calculate distance between p1 and p3. Okay, that's what I want to do. And now, what should I do the next? After this, I would like to do just one more thing. Let's say we also got string and also description number 1. Okay, it's going to be p1.get description. Okay, that also doesn't take any input value. And also, I will also get over here double description number 2 is going to be p3.get description. Again, you can see in these 2 lines. Let's see if I spelled it correctly. Okay, get description over here. Oh, actually, should that be double? Be careful, because p3 so this is also a very common error. Let me explain to you. Okay, so now if you move your mouse over here, type mismatch cannot convert from string to double. What does that mean? Because we are trying to call get description. Get description over here, you can see that the return type is actually string. That means whenever you try to call this method here, it's going to return back to you a string value. It's as if you try to assign the left-hand side to some string value. Okay, and now what variable type did we declare? We declare double over here. That's not right, because this part over here is going to be a string. You cannot assign a string to a double. You just cannot do that. Okay, so I'm going to say string over here. Okay, so now we got p1, p3. You can see this line here, line number 25, we are calling description. Okay, line number 25, we're calling get description. Line number 23, we are also calling get description. However, the objects on which we're trying to call get description is different. In one case, it's p1. In the other case, it's p3. So let's now print something to the console. Before I do that, I would like to reorganize the lines a little bit. Okay, so it's easier for you to see the comparison. Okay, so now if you go back here, so can I just cut this line here and put it after this? Okay, so now you can see more clearly in pairs over here. Basically, for this pair of method calls over here, basically you can see calling the same method, but the objects upon which we are calling the method is different, p1 versus p3. Similarly, over here is get description, and also get description being called twice, and also the objects being called upon is p1 versus p3. And over here we're just calling p1 get distance from p3. Okay, that's what we're doing here. So now let me just try to print something out to the console, and then after we've seen the output to see it works, and then I'm going to trace it on the iPad for you. That's the most important part for this video. Okay, but of course before we get there, we got to build something to get there. Okay, so now I'm just going to print it out. So system.out.println over here, I can say description of p1, and then I'm simply just going to say plus this description 1. Description 1. Okay, you know what? Let me even just to make it Yeah, let's just cut these two lines. Okay, just correspond to the order. Okay, how about that? Okay, so we'll do description 1 and also we'll do description 2. Okay, description of P3, which is going to be this description 2. Okay, let me change it. Okay, similarly, we're gonna say system.out.println over here, and then I'm gonna say distance of P1 from origin, which is 0, 0, and the distance is going to be distance 1, right? That's the return value from making this particular method call on P1. Okay, so it's going to be distance 1, and similarly, let me copy that. Distance of P3 in this case from origin will be, you can see by calling this particular method for the second time, but now the object being called upon is P3, and then it's going to be distance 2. Okay, distance 2 over here, and finally we can say system.out.println, and then we can say distance from, and then P1 to P3, and it's going to be, you can see over here we are saying distance, the object being called upon is P1, and then it's going to be distance 3. Okay, so now we'll say dist 3 over here. Okay, that's something we'd like to print out to the console. Okay, we're going to see that very quickly. Okay, if we try that, it was simply just going to run this. Okay, basically that's what you will see. First of all, let's look at the description over here. Description of P1 and P3 is going to be 3.0 minus 4.0. You can see P1 was created right here. Okay, it's going to be 3 and minus 4. So 3 and minus 4, that matches. And also minus 2, minus 7. P3 is over here. It's going to be basically along the y-axis. So the x coordinates will be 0, right? That's something we talked about in the previous tutorial video by calling the second version of the constructor. I'll leave it to you. Okay, and then what's the distance from P1 to origin? In this case, you can see P1 is going to be, let me bring it back. P1 is actually 3 and minus 4. It's going to be 3 squared plus minus 4 squared is going to be 25. And take the square root is going to be 5. Okay, you can do the math very easily. Okay, I'm going to leave it to you. And also the distance from P1 to P3 is also going to work. Okay, you can double check with the value. It's just correct. Don't worry too much about the number over here. Okay, so I'm going to trace the code with you to make sure it works as we expected. So now let's trace the code on the iPad. I already got a snapshot of the relevant fragment from the two classes. So this is the point class over here, and this is the part of the fragment I would like to trace in the point tester main method. Okay, so these are the two parts you want to pay attention to. Okay, so now let's do what we know already. Okay, so let me just use color to distinguish. Let's say for P1, I'm just going to execute, for the first line, I'm going to execute this calling to the first version of the constructor, which we did previously. And for that one, it's going to create basically an object of type points. Let me draw that quickly. Okay, as we said before, you have to know how to draw diagrams like this so you can know how to trace your program with objects. This part is going to be of type points, so going to be points. And for every point, we got x and y. So we got two fragments over here, so x and y. And now in this case, it's going to be 3 and minus 4. 3 and minus 4, and then P1, rather than storing the entire objects, P1 is going to just indirectly store the address of this particular object. That's why we draw the arrow like this. Okay. Similarly, for the second line, we're going to have this particular one. Okay, we're going to create P3. Okay, by calling the second version of constructor. We also did the tracing for you, how this object can be created in the previous video. In this case, we're going to have basically calling this particular constructor, which also has a type point. So we just have another object over here of the same type, which is point. If they are the same type, that means the structure is going to be the same. For point class, you also got x and y. So we also got two fragments over here, x and y. And then it's going to be basically 8, and also because it's along the y-axis, so the x is going to be 0 and the y is going to be 8. Okay, if you are wondering about how to trace this particular constructor over here, which is a little bit slightly more complicated using if statements, you can refer to the previous video. Okay, and then we're going to store the address of this object in P3. So P3 indirectly is going to point to this object here. Okay, that's after these two lines. So now let's focus on how to use the dot notation. For example, this one specifically. Okay, so let me just try to give you a very quick explanation, but it has to be thorough, of course. So now let's focus on this particular expression over here, p1.getDescription. Okay, I want to really get it very clear to you. So when I say p1.getDescription, p1.getDescription. Okay, first of all, this is so-called a method call, the whole thing. And in general, of course, for this particular video at this point, we are making things simple. You only see a single dot. However, later, you might have as many dots as you like in a single expression. But for now, let's keep it simple. So it's called a method call. Okay, so there are three parts of the method call. So separated by a dot. Okay. So now I want you to, first of all, to understand this. The first part, I'm going to highlight it in yellow. This part over here, okay, this is the method that's being called. Okay, so over here, this is the method being executed. Of course, in general, you might have some input values if you're calling a different method. For example, distance from. Okay, and then you also have the second part, which is the objects over here. Let's say P1. Okay. This is really important to notice. Okay, this is the so-called context objects, P1. So whenever you're trying to do a method call, the context object is really important, because when you change from one context object to another, for example, you change from P1 to P3, every context object, as we have seen before, might be created differently, which means each context object might have their x and y coordinate values being different. So that means even though you're calling the same method, but because the context object is different, so the way you calculate, even though the way you calculate distance is the same for the origin, but because the x and y coordinates are different between context objects, so the return value would be different. Okay, but we're going to see that. And then finally, this is the third part, which is the dot over here. Okay, I'm going to put it here. So the dot simply means locates the objects whose address is stored in P1. Okay, so dot notation. So the dot is a very important notation that you want to learn for OOP. Whenever you're using a dot, to the left-hand side is actually a context object. As we said before, like an object variable over here, let's say P1 is actually of type points. So that means P1 doesn't store the object entirely. P1 only stores the address of the objects. So now when you use dot, that simply means go to the memory location for the P1 storing address and find that objects out. Which means when you say P1 is like over here, just the address itself. When you say P1 dot, that means you're following this particular arrow over here and then find out this particular objects that's being created. Okay, so P1 versus P1 dot has a very different meaning. Okay, so now I want to make sure that's clear to you. Okay, after this, we're going to say for this particular object over here, we're going to execute the block of code that's named getDescription. Okay, that's what we're doing here. Let me just trace it quickly with you. Okay, so now let's say for this particular line, I'm going to say here p1.getDescription. Okay, you can see over here, the context object is actually P1. Context object means that's the current object that we are considering right now. Okay, if you move on to the second line over here, where we're calling the same method, but now the context object is different. In this case, it's going to be P3, which means the current object we're considering will be P3 instead. So it's really important for you to know which context object we're talking about. Let's say for this particular one, okay, let me use a different color here. Let me use pink. So now in this case, the context object is actually P1. So that's a context object, CO, context objects. So that means when I go to the getDescription method over here, context object is basically this. Okay, so that means we're going to replace every occurrence of this by P1 in this case. So you can see over here, this dot x, that's why we actually say, I say sometimes, often, if you simply put this over there, even though it might be a little bit redundant, but it makes it easier for you to trace the code. So every occurrence of this is going to be replaced by P1 over here, and also this would be just P1. Okay, so now it boils down to, so once the very first call we are trying to make to get description, it boils down into something like description is simply P1.x and also P1.y. That's basically what we're doing over here. But what does that mean? Remember I said dot before. Dot simply means look up the address that is stored in the context object P1. In this case, P1 stores the address for this particular object. So we go there, and then we're going to look up this particular object over here. So we go there, and then P1.x is 3 in this case. So P1.x in this case is simply 3. And P1.y is going to be -4. So we got 3 and -4 in this particular case. So that's why we simply get 3 comma -4, right? You can see starting with the opening parenthesis, with a comma, and with a closing parenthesis. But 3 and -4 are the attribute values we get. That is why when you look back to the Eclipse in the console, we actually got 3 and -4. Let's not worry about the point 0, okay? You get the idea. Okay, what about the second call over there? When you look at the second call over here, you can see the context object is now P3. Okay, so now this is the context objects, and we're calling the same block of code with the name getDescription. So that means we're calling this particular method for the second time. When you're calling this method over here, you're going to replace again every occurrence of this by the context objects. You can think about when you are trying to define the method, like over here. This is where we define the method. Okay, this is definition. And this is where we call or use the method. When you define the method, whenever you talk about this, basically somehow when you try to use the call, try to use it, the context object will be replacing this. Okay, that's something you want to keep in mind. Okay, so now in this particular second call, we're going to replace every occurrence of this by P3 being the context object rather than P1. Okay, so now every occurrence of this is going to be replaced by P3, and this is going to be replaced by P3. So what it boils down into is we're really doing P3, let me put it here, we're doing P3.x and also P3.y. Again, dot simply means P3 over here stores the address of some objects, and dot simply means look up the address and go to that particular object in the memory. So dot simply means go to that particular object over here. So this is the object we're looking for. And now when I say P3.x is referring to this particular x, which is 0. And then when I say P3.y is referring to this particular y over here, which is going to be 8. So that's why we get 0 and then 8. Okay, so that's how these two method calls are being executed. Okay, hopefully you get an idea. Okay, so I would like to just trace this again for another two accessors, just to for completeness. So let's first trace the get distance from origin, which takes no input value. Okay, let's switch to a new fresh page. Okay, it's absolutely clean. So we got two possible context objects, which can be P1 or P3. You can either say P1. Okay, let me see. Show you the two lines I would like to trace. The first one would be over here in pink. I would like to treat either this one over here, where the P1 is the context objects, or it could be number 2 over here, where P3 is the context objects, but we're calling the same method. Okay, so again, you want to notice that the essence for OOP is, even though you're calling the same method, but because the context object might be different, so the effects will be different. Okay, so now let's see exactly what's going to happen. Okay, so now assuming that we already got these two objects created, so let's say when the context object is actually P1, and we are calling get distance from origin. So that means we are calling this method over here. We are basically executing this block of code where the every occurrence of this over here, in this case, every occurrence of this is going to be replaced by the context object. In this case, context object over here is simply just P1. That means every occurrence of this is going to be replaced by P1 over here. Okay, So think about what's happening here. So that means what we are doing here is p1.x multiplied by p1.x and plus, okay, and then over here, I think this one here, from previous example, I actually should have declared that to be this.y. Okay, let me change that very quickly so you will see the idea. Okay, so it will be the same. It's a little bit redundant, but it would be easier for us to trace. If I just go back to my code over here, if you simply just go back to get distance from origin, okay, let me be consistent. This.x, this.x, y here also works, but implicitly it will be just this.y. Okay, you can also change that to this.y. Okay, so let me just do it on the iPad over here. So this one over here is really this.y. Okay, let me just change this quickly. So this one over here is really this.y as I just modified the code. And now this occurrence of this is also going to be modified to p1. Okay, it's going to be modified to p1.y to the power of 2, right? That's basically what math power will do. Okay, and think about the values we are applying over here. P1 over here is the context object that we are talking about, right? Remember, P1 is over here. We are using it. And P1 is only the address for the objects over here. And then dot is going to look up the location for the objects and go to that particular object. P1.x is really following this particular link and go to x. So that means we got 3 square, right? So the p1.x will just be 3. 3 times 3 will be 3 square. Plus, and also p1.y is going to be minus 4. And then we take the square root. That's exactly the calculation we'll do, okay? And then eventually, once you're done with the calculation, you simply return the distance accordingly, okay? That's the very first call to get distance from origin. What about the second call? In the same way, we're going to execute the same block of code, do the similar replacement. Now the only difference is the context object will be P3 rather than P1. Okay, let's see very quickly. So now the context object for this line here will just be P3, and we are calling the same block of code. Okay, so we're calling the same block of code for the second time. And now every occurrence of this is going to be replaced by P2. Sorry, not P2, P3. Okay, context object is actually P3. And also replace every occurrence of this by P3, and also this is now replaced by P3. So that means we got P3.x multiplied by P3.x, also plus P3.y to the power of 2. You can see the pattern for the computation is really the same. It's just that we have to replace the context object by, we got to replace the this by the context object, either P1 or P3. And now in this case, P3 is storing the address over here, and dot is going to follow the link to the object in the memory, and then P3.x is referring to 0 over here. It's going to be 0 square. And also P3.y is basically following this. Is going to be y here. It's going to be 8. So 8 square. Okay, so that's what you would do. You can see the similar pattern for the computation as before. It's just that the value that we are trying to do is different, simply because the context object is different. Okay, and then once we calculate this, we're going to return the distance accordingly. Okay, that's why you see in the console that's the value from P1 that get distance from origin is different from P3 that get distance from origin. Okay, hopefully you see that. Let's trace one more method. Okay, which is this one over here. Okay, let me again switch to a fresh page. Okay, again, just don't forget we just changed the y to this.y. Okay, it will also work. Now let's trace a different method over here. So now if I try to trace this particular method over here, what's going to happen? Okay, so now let's first think about what the context object is. The context object will be the object name to the left of the dot. Okay, in this case, the dot is over here, and the context object will just be P1. Okay, P1 is going to be the context object over here. Okay, context object, and we're calling this just for the first time, get distance from. And P3 over here is basically what we are expecting as the other, right? Because P3 is of type point. P3 is of type points. That's why we can pass P3 over here as other. So that means every occurrence of other is going to be replaced by P3. Let me do that very quickly. Every occurrence of other is going to be replaced by P3 and also replaced by P3. over here, and every occurrence of, let me just use a different color. Every occurrence of this is going to be replaced by P1, which is a context object. Every occurrence of this is going to be P1 and also P1. Okay, you can see we have to make sure we replace both the context objects accordingly for this, and also we have to replace the input parameter over here, which is the input value P3 for every occurrence of the input parameter other. Okay, so these are the two replacements you want to be comfortable with. So now what's going to happen? So now what it boils down into is as follows. So what we will get is, we'll say distance over here. I'm just trying to write it down completely for you. Okay, it's going to be math.square root. Okay, it's going to be mathematically like that. And now math.power is going to be p1.x minus p3.x, and then to the power of 2 minus, okay, the square root go, I'm running out of space, but it's going to be p1.y minus p3.y to the power of 2. Okay, that's exactly what we're doing here, right? So now if you look at that, p1.x is going to follow this particular address and go to the memory location, so that's why we have the dot notation here. p1.x is going to be 3, right? So this is going to be 3. And what about p3.x? p3.x, so you can say p3.x. p3 is this address over here, and we say dot. So we're going to follow this and go to p3.x will be 0. So we got 3 minus 0 to the power of 2. And then similarly, we do the y field as well. So p1.y dot, so p1.y is going to be minus 4 over here. Similarly, when we do p3.y, again dot, so p3.y is going to be 8. Okay, so that's the kind of the calculation we do for this particular method call. As an exercise to strengthen your understanding, I would like you to consider the following method call. Okay, let's say I say double distance. Okay, rather than distance 3, I'll say distance 4. Is now let me swap the context objects and the input objects. So rather than P1 being the context object, I would say P3 dot as the context object, P3 dot get distance from. And then I'm going to pass P1 instead. You can see I basically now the context object will be now P3 and the input object will be P1. So what does that mean? That means we're going to execute the same block of code for the second time. But now every occurrence of this is going to be replaced by P3, and every occurrence of other is going to be replaced by P1. And what will we have? Let me just, you want to trace this for your own understanding, but what you will get is something that's mathematically equivalent. What you will get is rather than, for example, 3 minus 0, you will get 0 minus 3 square, and rather than minus 4 minus 8, you will actually get 8 minus 4, and then square, and then take the square root. So the pink one is actually the expression you will get, which is completely equivalent to the blue one. Okay, so that's something I really want you to trace for your understanding. Okay, so now let me recap very quickly for this video, and then we'll have you study for that, and then go to the next video. Basically, for this video over here, we are trying to define one kind of method, which is called accessor, which means we always have a return type, and you want to have a single return as a beginner. And then you're just doing some computation inside, and then you can feel free to use this keyword whenever you want to refer to the attribute variable. In this case, it will be the x and y that we declare for this particular class over here. And when you actually go to the tester over here, you actually want to make sure always you know what the context object is. So whenever you're trying to make a method call, the context object is very important. And finally, let me re-emphasize again, what's the role for dot? Because we know that for all the object variable P1, P2, P3, P4, each one of them stores the address only for some objects. So P1 only contains the address, and dot simply means look up the address and go to the memory location accordingly and find out the objects. And once you find out the objects, depending on what the context object is, if the context object is P1, that means the object corresponding to it will be this particular object with 3 and minus 4. If the context object is actually P3, when you say P3 dot, you're actually going to follow the address and go to a different location in the memory, and you're going to see 0 and 8 differently, right? So make sure you're very comfortable with this idea of about a dot, about the context object, and about the replacement for this. Okay, and next video we're going to talk about how you can define the last kind of method, which is called mutator, to modify the attribute values.